Hey everybody, it's me, Miss Black again. Okay, now that we learned about how you use trigonometry to solve right triangles, that's not just where we can use it. In fact, we could use trigonometry to find missing sides and missing angles of any type of triangle. So the next thing we're going to talk about are triangles that are not right. First of all, new vocabulary word. A triangle that is not a right triangle is called oblique. So that could be an acute triangle, it could be an obtuse triangle, it could be scalene, it could be isosceles, it could be equilateral. All those names you heard in geometry are lumped in one sum, oblique. So if you're an oblique triangle, you are not a right triangle. First thing, if you are not a right triangle, you could not use Pythagorean theorem. So I need to state that up front because a lot of times that's where our mistakes are made. If you do not have a right triangle, you cannot use Pythagorean theorem. If you do not have a right triangle, you cannot use SOHCAHTOA. So what we have to learn today is how we're going to apply trigonometry to a triangle that's not right. Well, what happened is they came up with a new rule or a new law, a new formula, whatever you want to call it. And the formula or law we're going to talk about today is called law of sines. Now, it would do you guys a disservice if I didn't show you where they got the law from. It didn't just fall out of the sky. You know, SOHCAHTOA was easy to understand because it was based on the definitions of what sine, cosine, and tangent were originally. Only instead of using the letters X, Y, and R, we used the words opposite, adjacent, hypotenuse. So that made sense where SOHCAHTOA came from. But this law of sines is a new rule, and I want to show you where it came from. So if you look here, here is a triangle, ABC. Is it a right triangle? Absolutely not. That's not 90 degrees, that's not 90 degrees, and that's not 90 degrees. So our three angles are not 90 degrees, so it is not a right triangle. But you could take any triangle and make a right triangle inside of it by dropping a height, which is called an altitude. So think about it, when you go to the doctor and you measure your height, you stand up really tall. That means your feet are perpendicular with the ground. So inside this triangle, I can draw in our height altitude. And that would make a 90-degree angle here and a 90-degree angle here. So really, in triangle ABC, I have two right triangles. And let's just name this point, let's call it D, like I did in the notes. And we know if this is angle A, this is side A. If this is angle C, this is side C. And all of this would be side B. So just like we've been doing. Okay, let's label this H for height. Okay, so I just wanted to have my picture labeled. Now, what happens is, if there are right triangles in here, we could use with right triangles SOHCAHTOA. So what they did is they looked inside this little triangle, which is a right triangle, ADB, and they picked one of the acute angles. They picked the acute angle A. And they said the sine of this would be opposite over hypotenuse. And if this is angle A, the opposite side would be H. And the hypotenuse in this picture is C. So they wrote the sine of angle A is opposite H over the hypotenuse C. Everybody agree with that statement? And we could cross multiply this statement and get 1 times H is H, and C times sine A is C sine A. So all I did was look at this right triangle, I picked this acute angle down at the bottom, and I did the function sine. I'm going to do the same thing with this right triangle. I'm going to pick the acute angle at the bottom, which is angle C. So I'm going to say the sine of angle C. And the sine again is opposite. Well, if this is your acute angle, the opposite side is H, the height. And in this picture, here's the right angle, the hypotenuse is A. And I'm going to cross multiply, and I'm going to get H equals A sine C. So what I did is I took a regular, normal triangle that was not right. I dropped down the height, which made two right triangles, and I just decided I picked the acute angles at the bottom, and I did the sine value. Now, what mathematicians now have here is two equations. And you learned in algebra to put two equations together, you could do substitution. Replace one for what it equals. Well, if you look, do you see where it says h equals? So can I put that expression in the spot for h? So that makes the equation c sine a. Putting that in the spot for h, and that will equal a sine c. So now instead of having two separate equations, we have one equation. And what mathematicians did is they took both of these sides of this equation and they divided it by the same thing. They divided it by the angles. So they divided by the sine of A and the sine of C. They divided by both. The sine of A, the sine of C. So what happens over here on the left, sine A would cross out and they would get C over the sine of C equals. On this right side, sine C would cross out. You're dividing the same thing. And you would get A over the sine of A. And if you look right there, that's where the law of sines comes from. The law of sines comes from doing that calculation. You could take any triangle that is not a right triangle, drop a height and altitude, make the two right triangles, and come up with this system of equations. Well, you're going to say, well, do they have to label this angle A? No, this angle could have been labeled B, which meant that side would have been B, which means we would have had B's in here. So the law of sines is a calculation of doing all these right triangles. So the law of sines is side A over the sine of angle A equals side B over the sine of angle B equals sine C, side C over the sine of angle C. This is the law of sines. It's these three fractions. Now, I know when we just developed it, we only got two. But again, who said this side I had to label A? I could have had the letter B here, and this would have been a B, and then this would have been B over the sine of B. So the law of sines is side over angle, side over angle, side over angle. And it's called the law of sines because we're using the trig function sine only. Now, to work this law, you're not going to work with all three fractions at once. You're only going to work with two of the fractions. Because if you only have two of the fractions, then this is a proportion, and to work with this equation, a proportion, you would cross multiply. So the hardest part we're going to have today is deciding if this is the law of sines, how do you decide which of the two fractions to use? And that's not really that hard because just think about, you're going to look and see what information is given. Okay, let's look at our notes at example 1. Okay, so example 1, this is what you're given. Angle A is 32 degrees. Angle B is 81 8/10 degrees. Side A is 42 9/10 centimeters. And the directions say, solve the triangle. Well, we've already discussed this. Solve means find all the missing parts. Every triangle has 3 angles and 3 sides. There's always 6 parts to a triangle. You're given 3 parts, we have to find the other 3. What I want you to notice that's different in this section is look at the angle measurements. 32 and 81. Could this be a right triangle? No way. Right now, if you just off the top of your head add 32 and 81, you're at 113 degrees. So you know this can't be a right triangle because all 3 angles in a triangle add up to 180. And this already adds up to 131. You can't have 90 more. So when you draw the picture here, do not draw a right triangle. Just draw an acute triangle. Why did I say acute? Because that angle's less than 90, that angle's less than 90. It doesn't matter how you label, A, B, C. First thing we talked about, like in the previous sections, put your information in. Angle A is 32 degrees, got it. Angle B is 81 8/10 degrees, got it. Side A, which is across from angle A, is 42 9/10, got it. Your job is to find the 3 remaining parts. Again, let's do this carefully. Let's see if we can use geometry first, and then whatever's left we'll use trig. Well, we know we have two angles, and we know three angles. The measure of angle A plus the measure of angle B plus the measure of angle C have to add up to 180 degrees. That's a straight rule from geometry. So angle A is 32 degrees. Angle B is 81 and 8/10 degrees. And if we add that to angle C, we should make 180. So let's get our calculators out because this will be an easy calculation. We will subtract from 180 these two angles. Okay, so I'm going to say 180 minus the 32 minus the 81 and 8/10, and that's what my third angle is. So the measure of angle C is 66 and 2/10 degrees. Everybody's okay with that? Great. Remember, this is an angle in decimal degrees. This angle is in decimal degrees. All righty, so we got the three angles out of the way. So the next thing we have to do is find the sides. We are missing side B, and we are missing side C. Again, is this a right triangle? No. So we cannot use Pythagorean theorem, and we cannot use SOHCAHTOA. SOHCAHTOA is the definitions of sine, cosine, and tangent related to a right triangle. So the only way to find a missing side of a triangle that's not right is to use law of sines. Okay? Now, we're not going to use all three fractions. We're only going to use two. The first fraction you use is the one you know both the angle and side for. So everybody look at your information that was given. Which fraction can we fill in when we know both the angle and the side? We know side A and angle A. So that's the first fraction we're going to use. So we're going to use, let me get a different color here, A over sine A. Because we know side A is 42 and 9/10, and we know angle A is 32 degrees. Good? The next fraction is what we want to find. So make a decision. Do you want to find side B first or side C first? Well, if I can find, I like to go in alphabetical order. We're going to find side B first. I know angle B. So you all with me? I can do that. The other fraction we're going to use is B over sine B. So side B I don't know, but angle B is 81 and 8/10 degrees. Everybody okay? All we had to do, law of sines, there's three fractions. You have to choose two. The first one you choose is the one you know both the side and the angle for. There it is. We know side A and angle A. The second fraction is the one we want to find. If we want to find side B, then we need to use angle B. Just like SOHCAHTOA, this is a proportion. We're going to cross multiply. Miss Black likes her variable on the left. So we're going to do B times the sine of 32 degrees equals. Again, we're going to take this decimal, 42 and 9/10, and multiply it to this. Do not multiply the 42 and 9/10 to the 81 and 8/10. This is an angle measurement. This is not. So this number goes in front, 42 and 9/10, times the sine of 81 and 8/10 degrees. Now, who are we trying to solve for? B. To get this word sine off of B, we're going to divide by the sine of 32 degrees, divided by the sine of 32 degrees. So first I'm going to write B equals 42 and 9/10 times the sine of 81 and 8/10 degrees over the sine of 32 degrees. When I was in school, we left that. You guys have calculators. All you have to do is type that in. Now let's talk a minute before we type it in. There are two things going on in the numerator. You have this decimal number, 42 and 9/10, and you're multiplying it to the sine of 81 and 8/10 degrees. You have this trig function in the denominator, which is connected by division. When everything is connected by multiplication and division, you type it in the way you write it. You don't need any parentheses here. So let's go sit down and get out our calculators. Okay? In our TI 36 Pro, first of all, what degree mode do we have to be in? Degrees. We're going to type 42 and 9/10. We're going to hit sine. we're going to type 81 and 8/10 and close it. We don't need the degree symbol. We're in degree mode. Divided by sine 32 and close it for degrees. You always close the angle measurement. So whether we're using the Pro or the 30 plus, we're going to do the same thing. And there is our answer. Again, we've discussed this. Do not round your answers till the very end. Okay, that's important. So what I have here, I'm going to write out my official answer. And then on your homework, especially read directions. This said to round to the nearest tenths. The 1 is in the tenth spot. There's a 2 behind it. So this would be B is approximately 80 and 1/10. And our units was centimeters. So we found 2 out of 3 pieces. We found angle C. We found side B. Now we got to find side C. Here's where the boo-boo is going to be. You guys are going to put the sides in and want to do a squared plus b squared equals c squared. Is this a right triangle? No. No Pythagorean theorem. No SOHCAHTOA. None. In order to find side C, you got to do the same thing. You got to use law of sines again. Now, here's the problem. When you go to get the next answer, you do not want to use a rounded answer. So guys, when we go to set up law of sines now to find side C, well, obviously to find side C, the first fraction we're going to need is the C fraction. Okay? So I'm going to erase this. If I want to find side C, I have to use this fraction for law of sines. C over sine C. Okay, now you're going to say to me, well, I don't know angle C. Yes, you do. You have it here. Was this a rounded answer? No, this was exact. This was your exact angle. This was your exact angle. This is what you got out exactly. So you can use that. It wasn't rounded. It's exact. So we don't know side C, but we know angle C is exactly 66 and 2/10 degrees. So the question is, what other fraction do we set up? Do we do the A's again, or do we do the B's? Again, you always want to use numbers that are exact, not rounded. Do not use the B's because you found side B and rounded it to 80 and 1/10. You can't use that 80 and 1/10. Your only option is, if you use the B's, to use that big long fraction, the 80 decimal point 1 blah, blah, blah. I don't want to use that, do you? So my rule of thumb is when you're setting up, always use the information given. So if I go back to my picture, I was given side A, that's exact. I was given angle A, that's exact. I'm going to do the same thing. I'm going to use A and sine A. So side A and angle A. Make sense? Now all we're going to do is cross multiply. I'm trying to find C, so I'm going to put C on the left. So this is C sine 32 degrees. I'm going to multiply this decimal to this trig function. The decimal goes in front. The trig function goes behind. To solve for C, I got to divide by sine of 32 degrees. So in my world, when I was in school, we wrote C equal 42 and 9/10 times the sine of 66 and 2/10 degrees divided by the sine of 32 degrees. Nowadays, you guys don't have to stop there. Now you can go type this in your calculator. So let's go. So I'm going to switch out calculators. I'm going to use the 30 now, just to show you the same thing. What mode do I have to be in? Degrees, I am. And I type how I read it. 42.9 sine 66.2 and close it for the angle. Angles have to be closed. I don't have to put a degree symbol. I'm in degree mode. Divided by sine 32 degrees and close it. Hit equals. And there comes our length of side C. Is everybody okay with that? Everybody's good? All right, I'm going to take that. So I always write down the exact answer first. So there's our exact decimal value for C. The directions say round to the nearest tenth. 0 is in the tenth spot. There's a 7 behind it, so it'll round up to 74 1/10. Put your units, centimeters. So that's how you use law of sines to find a missing side of a triangle that is not right. The next example in your notes is just an application. It's a word problem for you to practice using law of sines. Okay, I'm going to see you in the next video where we have to go more into detail about this.